Hello everyone and welcome to today's session on Kubernetes deployments. Previously we have discussed about two other Kubernetes objects called pod and replica sets. Today we're going to be talking about deployments. It is also a Kubernetes object and it is kind of a manager. Like you see the manager in offices who supervises over the employee or the other responsible who interacting with the lower level. Okay? The deployment is like that. Now the thing is, what is deployment in a broader term? What is it? Well, deployment is first of all a high level object, high level object that let's say manipulates pods and replica sets. We're going to get to the what do I mean by this? What is the high level term here and how it manipulates the pods and replica sets. Another thing that is really good, or you can say a characteristics of deployment, that is we can update. It is a part of the manipulation. We can update the deployment, update the pods and replica sets to it really easily without this is one of the characteristics of deployment. Another thing is that the deployment like replica set, we can scale it up and down. Scale it up and down. So this is overall what is deployment. Deployment is an object, Kubernetes object, which basically manipulates these two objects, pods and replica sets. Now here I have high level. So what do I mean by that? And let's continue with the details. So first of all, what did I mean by that? We all know that suppose this is a container. We all know that pods encapsulate a container, right? Yeah? Yes. And a pod or multiple pods of the same exact pod, replicas to be precise, are encapsulated in replica set. It is basically encapsulating the replicas of the same exact pod. Here it is only out and deployment that holds the replica set. The whole. So now you might have guessed what did I mean by high level. Okay, as you can see, the, at the very bottom there is container. The container is encapsulated by pod. The pod is encapsulated by replica set with its copies, and the replica set is overall inside a deployment. So this was the explanation of high level. Now, another term that I have used is that it manipulates pods. What do I mean by that? Well, by that I mean that first of all you can create also replica set through deployment. You can update also replica set through deployment. You can scale up and down pods replica set through deployment. You can even delete them. You can delete the whole thing by deployment. So this was the basic thing about deployment. Okay. Again, since as you can see, it is covering the whole canvas here. So whatever inside it, replica sets and pods, it can do whatever it likes with them. Okay, you can update it, you can delete it, you can create replicas, etc. But the basic task of deployment is scaling and updating. Fine? Okay. So this was the basic idea about the object or deployment and why do we need it. Okay? Because it gives us a high level interaction. Another thing to be recalled is that scaling up and down is something involved or related to auto healing and auto scaling in Kubernetes. Okay, and we do this thing through deployment. Auto healing meaning that if a pod goes down, automatically it will be created. We have said that it is maintained by replica set. Okay, but replica set itself is inside deployment. So overall deployment set triggers replica set, and replica set fixes the problem by creating a new pod. Okay, like if you want a bit more details, like if this pod goes down, then deployment set will trigger this one will create a new pod. Okay, and if two pods are not enough, then we'll tell the deployment set that we need more pods, then it will inside the replica set create more pod. Clear? Okay, similarly if you want to update anything, we will say to the deployment and it will take the necessary measures. Okay, fine. So we have covered up until now what is deployment and why do we need deployment and what does it do. Okay, fine. Now let's get to a bit of more technicalities. Okay, we will be referring the later part of our session from now on to the documentation, official documentation of Kubernetes itself. Okay, so let's see it. First of all, here as you can see, a deployment manages a set of pods to run an application workload, usually one that doesn't maintain state. Ignore the last part, but the thing is, it manages the pod. And another thing, a deployment provides a declarative updates for pods and replicas, the high level stuff that I mentioned before. Okay, and another thing is that in general we don't create pods or replica set. We create deployments, because the thing is if you create deployment at first, okay, if you create the deployment in the YAML file, then it will automatically create a replica set inside it, automatically create pods, the number of replicas you need. Okay, so it does it automatically, and I do not have to create a pod, then make a replica set and make the deployment. Then no, I just need to create the deployment and it will automatically create these other stuffs. Okay, pods and replica set. How? Let me create one for you. So first of all, for that, in order to do that, let me go to Killer Coda. Killer Coda is basically a free website that lets you use it for 1 hour It's an isolated environment. Okay, so it doesn't bother with my local machine. Okay, it is completely isolated from whatever I have in my machine. Okay, so it's a very good thing for practicing. So let's reload it. You can just search it, Kubernetes playground killer coder, and you will find it. Okay, let's reload it. Yeah, let's go to the documentation. Yes. So in the documentation, there are some use cases. I have described this. Create a deployment rollout. This is basically updating. Declare new state. This is also updating. And this is rollback to. This is also updating. Scale up, the scaling part that I mentioned, and some other functionalities relating to scale up and down. So creating a deployment. Okay, let us create exactly what is mentioned in the documentation. I have copied it. Now let's go. Now yes, our killer coda is also ready. So let me check if I can make the font a bit bigger. Yes, fine, it's better now. So let's do vim. Let's name our YAML file called deploy.yaml. Press enter, press I to get into insert mode, then do paste. Clear? We have our YAML file for the deployment. Now if you want a revision of what it does, so let me give you a quick recap. API version, kind, metadata, and spec, these are must arguments. Okay, the metadata is the details of the deployment, mind it. Okay, deployment that we are about to create. The name of the deployment is going to be nginx deployment, and there's some manual labels that you can give here. An app having the value nginx. Okay, in the spec part, the replica is the number of replicas you want of your pod. The selector, if you have a pod, predefined or pre-created pod, it will match it. If you don't, it will still have it. Okay, you don't. Okay, the template is really important. Template is the thing based on which the replicas will be created. Basically it will create this template, and if any pod gets disturbed, dies, killed, it will create a new pod according to the template. So template is really important. Clear? So this is about the YAML file. Okay, it is exactly like replica set except for these two parts, the API version and kind. In the replica set we had other stuff. Here we have these exact things. Please remind and be careful about the case sensitivity. Okay, it has to be exactly the same as you can see here. Okay, fine, so let's save it. Escape colon WQ and enter. Now if you do ls, you will find there's our YAML file for deployment. So let's create the deployment. First of all, let me show you that there aren't any pod replica set deployments in our system, in our cluster. There's a service object. Ignore it if you don't know it. Just ignore. We don't have any pod, we don't have any replica set, and we don't have any deployments currently in our system. So we do have our deploy.yaml. So let's create kubectl create -f deploy.yaml and enter. Here you go, our deployment is created. Now let's do again kubectl get all and see the magic. Yes, what did I tell you? Exactly what I mentioned here, that it will automatically create replica set and pods along with the deployment set. As you can see here that 3 pods are created. Since we have mentioned replica equals to 3,
a deployment object is created along with a replica set. Clear, guys? I think I'm clear on this one. Okay, so we have seen the creation of Kubernetes deployment object, how you can do this. Okay, I'm using the documentation for clear idea. Okay, so we are done with the creation part. I have explained all the arguments related to the YAML file also. So in here, these are some explanation of the YAML file itself. Okay, okay, we are done with this. You can have a look, have a little read. It is the whole deployment part is, I guess it will take 30 minutes max if you go through the entire stuff. Okay, so now we'll be going to studying the updating of a deployment. Okay, updating of a deployment, and here are some examples. We are going to be using the exact example. What are we going to be updating? Okay, okay, let me show you something. I think it is here somewhere. mm, yes, yes, here it is. The deployments, a deployment rollout is triggered if and only if the deployment pod template is changed. Okay, so if and only if, so the pod deployment will update if and only if there's a change in pod's template, the YAML file template part you have seen here, the template part. Okay, if this changes, this is the pod template, right? So if this changes, anything we change here, let's say image, if you change the image, it will trigger a rollout. Okay, so this is what is it is saying. The deployments rollout is triggered if and only if the deployments pod template spec, as you can see, spec.template is changed. Clear? Okay, now let us change something. Okay, here let's say from nginx 1.16.1 to zero point 0.2, let's change this in our deployment. Let's copy this one, or you can do this one also, it's your choice. It's the same thing actually. Okay, let's copy. mm, okay, okay, let's do it. Yes, let me show you the YAML file too, to check what is the deployment nginx version we have used earlier. We have earlier used this one, that is 1.14.2. now we are going to be using 0.1. So let's clear for a better view, and let's paste it. Sorry, the entire command needs to be pasted. Let me again pick this one and copy it and paste it. I'm directly pasting. Okay, it is basically setting the image argument that you see here. Let me show you the image argument you see here. Okay, it is directly picking this one and changing the value. Okay, okay, fine. It is called imperative command. We are not directly changing it in the YAML file. We can do that also. Okay, let me then show you this, how you can change the YAML file. Okay, mm, we can go to vim and deploy.yaml, and here we can manually, by pressing I, and here we can do this. We can manually change it, and then again do this command, apply, kubectl apply. Okay, kubectl, if you do kubectl apply of the same thing, it will be changed. Okay, this is how you can do it in the YAML file also with the imperative command. So for now I'm going to be using the imperative command. So let's get out of the file. without changing the file itself. Okay, now let's paste our original command, which was this one. Where is it? Yes, copy and paste. Now you will be seeing that the changed version, that is nginx.1 rather than point 2, will be implemented, updated, and we will be seeing a message and the image updated. Okay, the image is updated. Now if you see the deployments in details, let's see the kubectl describe deployments dot apps. Yeah, see, it is now 1.16.1, whereas it previously it had point 0.2. So this is how you can update it. Now you might be wondering that is it for the deployments? No, the pod itself changed. All the pods, previously you saw 3 pods, right? All the 3 pods have changed in this process. Okay, now a question might be you might be having is that how is this happening? Okay, it is a broader topic, really broader topic, and it is called something called deployment strategies. There are different strategies of updating. Okay, there is if I'm not wrong, blue green. There's something called canary. There's if I'm not, it is roll out, rolling over, I guess, rolling over. Okay, let me just Google it out to have the precise name. Rolling update in deployments in Kubernetes. Let's see. Rolling update. Okay. Yes. So it is basically the default function. Okay, the default update strategy, the rolling update. Okay, I think it's not rolling over, it is just rolling. Okay, let's say it is rolling update. This is the by default. If you don't mention any strategies, then it will be the by default strategy through which the update will function. Okay, the blue green strategy, the canary strategy, there are other strategies. These are used for different purposes, but these are a bit advanced topic. Okay, we won't be covering those today. Okay, fine, but let me give you an idea what happens in this rolling update. What happens is that, suppose that this is your replica set inside the deployment. This is the overall deployment. Okay, overall deployment. So when you do the updating, what will happen is that the deployment will create a new replica set, Okay, suppose this is rs replica set 1, it will create replica set with the id 2, and in reality there will be a new replica set with a new id. Okay, I'll be showing you that a bit later. Okay, now what happens is that in your current version, suppose you have 3 pods, these 3 pods running, and you implemented an update. What will happen is that, first of all, the deployment will create a pod inside a new replica set, the updated pod, up updated pod inside the new replica set. After one pod gets created, what will it do? It will descale or downscale the previous one. Similarly, it will again create another updated pod with the updated configuration, and after it gets up properly, it will downscale the previous one again. So in this case, 3 new pod will get created with the new version, the updated version, and after completion of creating the new pods, the previous replica set will downscale to 0. So as you can see, the strategy is that one goes up and one goes down. Okay, this strategy is called rolling update. Rolling update, and this is the by default update strategy of deployment. Clear? Okay, let me show you actually what happened. Let me go to the command and let me show you. Here you can see, let me check if I yes, let me just descale the font size for better visibility. Okay, okay, fine. So as you can see, in my current deployment replica set, this is the replica set, scaled up replica set that has a number 558 at the last. It is currently 3. Okay, now a new replica set is created having the last digit CF, 9CF. Now at the beginning, a new updated pod is created, scaled up, and the previous one is scaled down from 3 to 2. See this? From 3 to 2. Again a new pod, updated pod is created in the new replica set. To it is updated to 2 new pods, and the previous one is downscaled to 1. And finally, the new replica set has 3 updated pods, and the previous one is scaled down to 0. So this is what I mentioned here, guys, that one goes up, one new updated pod is created, the previous one is downscaled 1 times. Okay, this is the rolling update. Here, why do we do that? Let me also tell you the reason. This is that it reduces the downtime. Okay, you are never cut off. The system is never cut off. Okay, rather the update is in portion. Okay, some part is updated and some part is not. Okay, it is a rolling process, a flow, a smooth flow. Okay, you never have to completely shut down everything and do the update and bring the system back on. Okay, it is not like that. So this is the facility or the main advantage in rolling update, that it is the downtime is really low. Clear? Okay, so let us again go back to the documentation. We have updated, we have done. In the process, if you might also get this message that waiting for rollout to finish. If the pods and the containers are really large, then you might have to wait a little bit. Okay, and after it is successful, you will get this message like I got, that the Nginx deployment successfully rolled out. Clear? Okay, so uh, they just done the kubectl get deployments to see the deployment numbers and a bit of the details. Clear? Okay, so the here you will find all the details that I have mentioned about the rolling update. Okay, the rolling update. Here you can see, for example, you will see that it first creates a new pod, then deletes an old pod. First creates a new pod, then deletes the old pod. Okay, clear? One goes up and the other goes down. So you can have a little bit read in this one. Clear? Okay. And I have also shown you this part, that how the scale up and down happens here. Okay. Okay, fine. Rollover, I think I made a mistake in the naming. It is not rolling update, it is, I guess it is rollover. Okay, so I'm a bit confused, guys. I'll check it later on. Let's not make it lengthy. Okay, but the concept is same. Okay, now similarly, like let's say you have done multiple updates, update 1, update 2. If you want to go back to an older version, you can do that also in deployment. Okay, how? Let's see how. You can see the rollout status. Let's see our rollout status for our deployment. Let's clear the screen, clear, and see the rollout status of our specific deployment. Press enter. Successfully rolled out. Okay, it is successfully rolled out. It is not stuck anywhere. If it was stuck in any problem, if there was any problem, that we would be seeing that it is waiting and nothing progressed. Okay, fine. Another thing that I am mentioning right now is that rolling back to a deployment. Okay, rolling back to a version. How can we do that? It is here. Let us go down. First, let's check our rolling history. Rollout history. Wait. Yes. See this? There's uh, we don't have a specific rollout in our case, but if you have done multiple rollouts, multiple updates, then here, as you can see in the documents, clearly you have revision 1, 2, and 3. That means there are 3 rollouts, and that means 3 updates, 3 versions. Okay, 3 versions of your deployments. Now you can go back to any version that you like. Okay, so this is rollout history. In our case, we don't have anything. This is why it is none. And another reason is that we only implemented one. Okay, so yeah. So how can we get to the previous version of our deployment? It is also mentioned here that one way is to do undo, rollout undo. And if you have, like here it had 3 revisions, right? So if it was to go to back to revision number 1 or number 3 or number 1, then you can specifically mention it also. Okay, like this, revision equals to, let's do this one, although we have only 2 revisions, we can do this, paste it. Okay, another thing, let me show you the current status of the overall cluster, how many replica set. Since we have done the update, now we have a old replica set and a new replica set, right? Like I mentioned here, that a new replica set would be created and new updated pods would get into this one. The older one would downscale, but it will still be present in the system. It won't get deleted. Okay, completely. It will stay there, but it won't be working. Let me show you. So let's do kubectl get all to show all of this. Yes, as you can see, our previous replica set. See this? No desired pods and no current pods running, because we have updated it to this new replica set, but it is still there. If we roll it back, then it might get into use. Okay, clear? Fine. Okay, fine. So what were we saying? To getting back to our previous update. Let me copy it again and just paste it. It is kubectl rollout undo. We are not, yes, we are just gonna be mentioning the revision number. If you didn't mention the revision number, it will go to the exactly one step behind. Okay, it will just undo. Okay, but if you mention it, rollout undo, that the revision number is 2, then it will go back to the exact revision number. Okay, so let's go to 1. Let's go to 1 and print, and the deployment is rolled back. Okay, again let's do the kubectl get all. Yeah, as you can see, it went back 10 seconds and 14 seconds and 12 seconds. See this, it went back to the previous update, so it a new pods were created of the previous configuration. Clear? A bit earlier it was, see, 13 minutes, 13 minutes, 13 minutes. Okay, the first deployment. Okay, then we updated it. Okay, again we went back, so it again got created. See this? Clear? I think I'm clear on this. Okay, so guys, this was about the updating of deployment set. So up until now I've covered how you can create deployment, and how it creates, what the theory behind it, how it creates replica sets and pods. And I've also shown you how it updates with a strategy, rolling update. Okay, and there are other updating strategies, but those are a bit advanced, so we won't be covering it in this session, maybe in a future session. Another thing that at the very beginning I mentioned, that you can do scaling, up and down through deployment itself. Okay, so now let's go to the scaling part. Scale, how we can do that? The answer is in the documentation again. Let's go to the scaling part. Yes, it is really simple, just this command scale. It is exactly like the replica set, just instead of replica set we have to mention deployment and the name of our deployment. Okay, and how many replicas we want. So let's copy and let's go to the code. Let me first show you all the pods, currently present pods. Kubectl get pods, 3 pods running, right? So let's change it to 10. Press enter and scale. Again, let's see the pod, and 10 pods are running. 3 pods from previous stage and the rest are newly created. Clear? So this is how we can upscale. You can also downscale similarly. Just reduce the number of replicas, let's say to 5. Okay, it's now scaled. Let's see this. Now you can see there is only 5 pods running in our cluster. Clear? So we can upscale and downscale. Okay, we can also do auto scale like we showed in the replica set session. We can do auto scaling here. We can mention the minimum number of uh, pods running and the maximum number of pods running, and it will upscale and downscale based on the CPU percentage. If there's much more needs of CPU, then it will upscale, uh, and if there's no such need, it will downscale. Okay, so it will be so efficient, right? The entire thing will automatically happen, so it's so much beneficial for us. Let's just show you. Okay, let's clear the screen. Now we have 5 pods running. Okay, so instead of 5 we will have always minimum 10 pods running, and at max it will go up to 15. Let's print. Yeah, it is auto scaled. As you can see, our deployment is now auto scale. Let's get the pods. And it is okay. It will take a bit time. Okay, don't worry, it will take a bit time. After some time you will see the new number of pods running. Let's see now whether it's running 10. Yes, see, it takes a bit time, okay, to run all the 10 pods. In industry you will have thousands of pods, so yeah, after a while we can see minimum 10 pods running. Okay, And let's go to back to the documentation. There's not much more here. The rest is basically you can pause the roll update, the rolling part. You can pause the update, you can again resume the update, you can watch it. Okay, let me show you then. Yeah, you can where is it? Yes, you can watch how this changes from this. Okay, how the numbers go up and down, how the type, the status goes changes. You can see it through this command. Okay, so there's some other sub commands. The main thing I have already discussed with you. Okay, just let me go through that very bottom, just simply explaining deployment status, when it will show progressing in the description. If you do kubectl describe, you will see that status is true and the type is progressing. Okay, when it will show complete, these are the conditions, situations. It will show progressing, and fail, the same thing. When it will show failed, you can have a little bit of reading. It won't take too much time, but I'm just giving you an idea here. Okay, there's not too much left here in the documentation. Yeah, rollout, clean policy. I have mentioned about canary deployment. It is an advanced topic, a bit advanced than this, so I won't be covering. It is an updating strategy. Okay, basically it is an updating strategy. Replica selector, a bit details on the arguments that you use in the replica set. And talking about strategy, this is how, this is a new argument that you can use in the deployment YAML file. Just mention the strategy and the name of the strategy, and it will update according to that. It can be strategy recreate, or the one that I have discussed, rolling update. Okay, okay, fine. So these are the arguments explanations, and I think we are at the very bottom. Yes. So yes, you can pause it, you can resume it. This. So yes, this I have just covered the entire documentation related to deployments. I've covered the main stuff, and the stuff that I didn't cover are really just for your read. Okay. But let me summarize for you what today I have explained. Today I have explained a thing called Kubernetes object. Okay, let me go at the very beginning to give you a overall summary. So our topic today was Kubernetes deployments. It is an object. It is a high level object that manipulates these two lower level object, that is pods and replica set. Okay, by manipulating I'm meaning it can update the pods and replica set, and it can upscale downscale those. Okay, what do I mean by high level? Well, basically the containers are inside the pod is inside the replica set, and the replica set itself is some inside something called deployment. This is why it is called high level. Another thing for high level, that you can update, upscale, downscale through the deployment itself. You don't have to create pod YAML file, you don't have to again create a replica set YAML file. No, just do the changes in the deployments and deployment configuration, and it will automatically apply to the everything that is inside it. Clear? Okay. And we have seen how you can create those. We can create just deployment, and it will create the pods and replica set for us automatically. Okay, we can even delete it. I haven't shown you the deletion part. You can just do kubectl delete, and it will delete the deployment. You can delete the pods, you can delete the replica set, whatever you like. Okay. Okay, another thing is that it will automatically handle the auto healing part, because we all know that replica set does the auto healing part. If any pod goes down, it will automatically create a new pod. Since the replica set itself is inside the deployment, it will handle the auto healing as well. And the auto scaling part I also discussed. Let me get to that part. So after creation, I've shown you how you can create deployment set. Then I have discussed how you can update deployment, and I have discussed that there are certain strategies There are a few strategies. You can have rolling update, you can have canary update, you can have blue green update. These are for different advantages, okay? But the default is the rolling update. If you don't mention anything in your YAML file of the deployment, it will automatically handle the updates through the strategy of rolling update. Clear? Okay. And I have here explained how the rolling update happens. It is basically a new replica set will be created, and one by one new updated pod would be created in the new one, and the previous one would be downscaled one gets updated in the new one gets downscaled in the older one. So similarly, the older one ultimately would downscale to 0, and the new one would upscale to the number of desired replicas. So this is how rolling update happens. So like this, we covered creation, we covered update, then we covered scaling. I've shown you how to upscale, I've shown you how to downscale, and I've also shown you in the uh, in the in the killer coder playground that how you can do the auto scaling also. Clear? So guys, this was about our topic of today, Kubernetes objects deployment. Clear? I've covered from the very first of the documentation to the very last, only the most important stuff, and the rest is for your reading. So yes, this was Kubernetes deployments, and that's it for today.